So we're going to be moving into this lab for the enthalpy of reaction, electrode potential, free energy change, and entropy. Basically, it's drawing everything that we've learned here all together. For this lab, the first step is the thermochemical study part using a calorimeter here. So we need to find the mass of the lid, the magnetic stir, and the coffee cup calorimeter all together and record them into a data table. So we just found the mass here to be 23.07 grams. And the next thing that we're going to need is some zinc dust, which hopefully you can see is very fine, but we'll put it on some wave paper. We're going to need 2.50 grams, or yeah. We're going to need 2.50 grams of this zinc dust. And over to the right here, you can see that we have our 2.50 grams of the zinc dust. The next thing that we're going to need is a 125 milliliters of this 0.166 molar copper sulfate. So we're going to go ahead and measure that out and put it into our calorimeter. Once we have it all in our calorimeter, we're going to need the mass of this plus the magnet inside plus the lid, which we'll go ahead and find out now. And the total mass here of this can be recorded on this line, 148.05 grams. As you can see, we've got our 0.166 molar copper sulfate in our calorimeter here. So we're going to go ahead and look at the temperature reading. It's been room temperature for a while now. So we're going to look there, 22.0 degrees Celsius is about what it is stabilized at. Just for the notes and keeping record of that. So that's another thing that you want to add here on the data table is you want to add the 22.0 degrees Celsius for the initial reading of the copper sulfate. We'll then be working and adding we'll be adding our 2.5 grams of the zinc dust that we measured out. And we're going to go ahead and put this into the calorimeter. And watch the temperature to look for a maximum. Okay, so here we are, got our thermometer there in the copper sulfate, and we can go ahead and add our zinc to it now, and we'll carefully watch the temperature level as it goes in there. We'll put on the lid. A second. And then watch this thermometer as we have it spin. Hopefully you can see here that the temperature level has stabilized at about 27.5 degrees Celsius. So it definitely went up with the addition of the zinc dust. That's another thing that we're going to go ahead and add to our data table. We're going to add the temperature after the addition of the zinc dust at 27.5 degrees Celsius. The next thing that we'll be doing is we'll be setting up a cell very similar to the one that we did last time we made one of these, with a zinc strip here and a copper strip. So we're going to go ahead and clean the zinc strip by scrubbing it with steel wool. And then we're going to rinse this with distilled water that we've got here. So we're going to need to dry this strip off so that we can dip it into our mercury chloride that we can amalgamate the zinc strip in. So we're going to go ahead and dip the zinc chloride into the end there and let it sit for about a minute. And then go ahead and flip this around and turn it into the other side. So once this strip has amalgamated into the mercury chloride solution, a concentrated solution, we're going to go ahead and rinse it again with some of our distilled water and let it paper towel dry and let it sit for a while until it's air dry. Very similar process here with our piece of copper. This one's way thinner though, so be very careful when handling the edges of this, especially after wiping it down with a steel wool. This can be very, very sharp and you don't want to cut yourself. And then just like the zinc, I'm going to go ahead and dip this or rinse it with some distilled water. Let it air dry, and you can pat it dry with some paper towel as well if you want to speed up the process. Now that the zinc and copper strips are both ready over here and are dried off, we're going to go ahead and make the cell very similar to the one that we made the last time. So the first thing that you're going to need to do is you're going to need to get about 80 milliliters of the zinc sulfate solution, recognizing this time that it is 0.1 molar as opposed to 1 molar that we used the previous time. So about 80 milliliters of this can go into the beaker here, and we're measuring this out using a graduated cylinder. The next thing to do is to put about 20 to 25 milliliters of the 0.1 molar copper sulfate solution. Again, this is 0.1 molar versus the last time we did it, and was 1 molar. So much diluter, more dilute. So we're just going to put some of this into our porous cup here. Like so. Maybe a little bit more. Into our cup there. And you can go ahead and put the cup into the zinc sulfate solution like that. So then we can go ahead and put our strips of metal into the solution. So the copper one goes into the copper solution, and the zinc strip goes into the zinc sulfate solution as well. Then taking our voltmeter, which will switch on to the 20 volt DC current here, and we can go ahead and clip the clips onto the two electrodes. Once the wires are connected, you'll see the voltmeter starting to read here. And it's just continuing to climb here, getting to about 1. You'll see here it's currently reading negative 1.08 on our voltmeter reading when the cell is constructed. You'll remember that last time this number was about positive 1 point something, just a little bit more than 1.00. So here, but the difference there is just that this time we ended up putting the black one on the copper and the red one in the zinc. If we were to flip this around, which we will in a second, you can see here that once we flip this around, the number goes to positive instead of negative. So this is probably the way you want it to be. Just accidentally put the wrong ones on the wrong ones. It doesn't matter too much as long as you know which wire is connecting and whether or not you have this the wrong way. So this is our electrode potential here that we can go ahead and record on our data sheet. We can record it right here. So 1.09 is the electrode potential for the cell. And as you can see from the bottom of the table, we're going to do some calculations here that you'll need to do on your own for delta T for the reaction, the mass of the solution, the heat from the system given off from the calorimeter part of this, the moles of copper ions in solution, as well as delta H in kilojoules per mole, delta G, delta S, and the K equilibrium value. So again, this is all kind of just a refresher of everything that we've learned so far, from enthalpy to entropy to spontaneity, and even a little bit of equilibrium in there. So hopefully that's a pretty good review, as you'll have to do some calculations here on your own. And with that being said, I do think we're done here, and hopefully this helps to connect some of these things that we've learned so far this year.